2016 Civil Engineering Set 2 Question 55. A tall tower was photographed from an elevation of 700 meters above the datum. The radial distances of the top and bottom of the tower from the principal points are 112.5 mm and 82.4 mm respectively. If the bottom of the tower is at an elevation 250 meter above the datum, then the height of the tower is. The relevant NPTEL reference has been listed. Let us assume an aeroplane doing vertical photogrammetry. So the camera has been fixed in the aeroplane at point O, which takes a photo at focal length f of a ground surface AB, and the surface is projected on the photo as AB. But here, since the object is a vertical object of height h, that is a tower, it will have a certain displacement along the height of the tower. So the bottom point of the tower will be captured at point B and the top point will be captured at point B1. So the relief displacement is given as the gap between the horizontal projection between the top and bottom of the tower. So if we call AB as R0 and AB1 as R, D will be given by R minus R0. This is our first equation. We can see that by comparing the triangles OAB and OAB using the concept of similar triangles, we can get OA divided by AB equals OA divided by AB. This would give F by R0 equals H by R. From this we can get R0 as F into R by H. This is our second equation. Comparing the triangles OAB1 and O capital A1 B1, we would get OA by AB1 equals OA1 divided by A1 B1. Using this we will have F by R equals H minus H by R. From this we will have the value of R as FR by H minus H. This is our third equation. The relief displacement is given by R minus R0. So that will be FR by H minus H minus FR by H. This would turn out to be FR into small h divided by capital H into H minus H. Using the value of R, which is FR by H minus H, we can convert this to RH by H, or we can also write it in terms of R0, that would be R0 H by capital H minus H, which will be our relief displacement. So in this case R has been given as 112.5 millimeters. R0 is given as 82.4 millimeters. The base of the tower is at an elevation of 250 meters from the datum, and the aeroplane is flying at an elevation of 700 meters from the datum. So using this we can find the capital H value, which will be EA minus E, that would be 700 minus 250, that would be 450 meters. Using the equation of relief displacement that we saw in the previous slide, that is RH by capital H, here D would be R minus R0, so that is 112.5 minus 82.4 equals R, that is 112.5, into the height of the tower small h that needs to be found, divided by capital H value that was calculated as 450 meters. H will be found out as 120.4 meters. So the height of the tower was found as 120.4 meters. The relevant NPTEL reference has been mentioned.